All right, so let's see this question now, stock buy and sell, right? So in this question, we are given an integer array, A, and we are given the length of that particular array, N, right? So this particular array, what it contains is, it contains the prices of a given stock on a series of consecutive days, right? So for example, on day one, the stock price was 100, then it was 180 on day two, day three, it was 260, day four, it was 310, day five, 40, day six, 535, and day seven, it was 695, right? So for these 7 days, 7 consecutive days, we are given the price of a given stock on each of these days, right? In that order, right? Now, what we need to do is we need to find, segments of, periods or days over here in this particular array in which we will buy and sell this particular stock to basically maximize our overall profit, right? So when I say segments, what I mean is that, for example, I buy my stock over here at 100, then I sell it at 310, right? So this will be one segment, right? Then I again buy at 40 and sell it at 695. So this will be my second segment, right? So like this, we need to find all the segments where we buy the stock and on the first day of the segment, and then sell the stock on the last day of that particular segment. And we select these segments in such a way that overall our profit is maximized, right? So that's what the question says. You can also pause this video and read this particular question once, and also maybe you can think of a solution on your own, try to write a solution for this on your own, and once you are done, maybe you can just come and check the solution here, right? Also, if you see, the out in the output, we need to return an array of all these segments, right? So for example, if you see over here, as we saw, like we buy at 103 and sell at 310 over here, so I just return 0 and 3 as the segment indices over here, and then I buy at 40 and sell at 695. So again, that segment I return as a different tuple over here in this particular array, right? So that's what we need to do. That's what we need to return, all these segments in a particular array, the starting and the end index of all these segments. So that's the question. Now, to solve this particular question, what we can do is we can follow a strategy, right? A simple strategy that we would follow in a real world case also when we are dealing with stocks, when we are doing some kind of trading. So what we will do is initially we will buy at the first position, right? On the first day, for example, we buy it, right, at 100. Now what we will do is we will keep traveling towards the right. I mean, we will just keep traversing on the next consecutive days, and we will keep traversing till we find a peak, right? When I say peak, till we find a peak price on a given day, right? And when we find a peak, that means after that particular day, the price should actually decrease, right? Then I will call that particular day's price as peak, right? So whenever I encounter a peak, I will just sell at that particular day, right? Because after that, my price is now decreasing, right? So, I mean, there is no point moving forward. I can just sell at that particular day itself, right? So then I will just sell at the peak, and then at the next day, on the next day, I will again buy that particular stock, right? Because now the price is lesser than the previous day. So again, I will buy at that particular day, and then again, I will repeat the process. I will keep traversing to the right, and I will keep traversing till I again find a peak. That means again a day whose price is greater than the next day's price, right? So then I will be able to call that particular day's price as peak. Again, if I find a peak, I will sell it that particular day, and again, consider that as a different segment, and again, like buy on the next day, right? That's what I will keep doing, and that's how I will keep segregating this entire array into different segments of buy and sell, right? So that's the solution that we can follow. Also, at the end, for example, if you see in this case, if I buy at 40, and at every point, if I keep checking if my the current day's price is greater than the next day's price or not, you will see that over here, once I encounter the last element, I can just handle that as an exception, that if I have reached the last element and there is no like day uh, next to this particular day, the current day, then I can just close the segment over here, right? So that is quite intuitive. So that's the the approach that we can follow. And to do this, again, we will use a two-pointer approach, because anyways we are dealing with windows over here to calculate the segments. So we will have 2 pointers, and to start, like, we can call them buy and sell pointer. right? So by pointer we can initialize to 0 to start with. Cell can be over here at first position, and then we can just keep moving the cell pointer towards the right till we identify a peak element. And once we hit a peak element, we will just sell over there, right? And then again we will buy at the next element, and then again reinitialize the cell to you know the next to the next element, and then keep repeating the process like that, right? So this is the entire solution. This is the entire intuition behind the solution. I hope you understood it. And if not, anyways, we are going to code this solution together, and that it will be more clear once you see the code, once you follow along the code, right? So now maybe we can jump to the IDE and code this particular solution. And before actually we do that, maybe we can also talk about the time complexity and the space complexity. So space complexity, we are not using any extra space over here, so it will be constant, it will be order of 1. And when it comes to time complexity, we are just scanning this particular array once, so it will be order of n, it will be linear time. So that's going to be the time complexity, right? All right, so now let's implement the solution that we just discussed. So what I'll do is I'll declare a function over here, stock by cell, right? And this will accept an integer array and the length of the array itself, that is n, right? Now what I will do is I'll just declare and initialize my by and cell pointers to 0, right? And what I will also do is I will declare an empty array result res, and what the purpose of this particular array would be, I will just keep appending the start and the end index of every segment where I'm going to buy and sell the stock into this particular result array, right? So the moment I actually buy and sell at a particular position, I will just keep appending that buy and sell position for every segment in this result array. And at the end, I will just return this particular result array as the output of my function, right? So that is the purpose. Now what I will do is I will just iterate over the entire price array, and I will just keep looking for the peak day, right? The peak price day, whenever the price of the stock was at its peak, right? And how will I identify that? I will just keep checking if the current day's price is actually greater than the next day's price or not. If it is greater than the next day's price, I can safely say that price after today actually started to decrease, and that's why today was a peak price day, right? So what I will do is I will just keep iterating over the entire array, and I will keep checking if my a of cell is actually greater than my a of cell plus 1, right? And I can check one more thing over here, that either my current day's price is greater than the next day's price, or as a different, like a other case, it could be that, my current day is actually the last day in the series of days, right? So in that case also, the current day will become my peak element, the peak price day, right? Because after that, there is no other day for me to compare. So what I will do is, I will check if my current day is actually the last index of the array. In that case also, I will consider it as the peak day, or if my current day's price is greater than the next day's price, then also I will consider it as my peak day, right? Now what I will do is I will just handle one more corner case, that for example, if I have got a peak day, if I've identified a peak day, I will just check if my cell pointer, if that current day is greater than the buy day or not, right? Because if my sell day and buy day are on the same day, then there is no point of making this trade. I will be buying and selling on the same day, right? That's why I need to check if my sell pointer is actually greater than buy. Only then I will declare it as a segment, and I will just append into my result array the starting and the end index of this particular segment, right? So that's what I will do. And then finally, what I will do is, since I have now sold at the peak day, I will be buying on the next day again, right? Because after that particular segment, again, a new segment will start wherein I will be buying on the next day after the peak day, right? After the previous sell day. So that's why I will do buy is equal to sell plus 1, like this, right? And then what I need to do is, regardless of whether I found a peak day or not, I will just keep incrementing my cell pointer to the next element, right? Because I have to traverse the entire array, right? And at the end of this while loop, my result array will have the starting and the end index of all the segments. And so I will just return my result array, that is res array, right? So this is the solution entirely. Now, maybe what we can do is we can quickly test this by printing out, you know, the result on a sample test case. And I can quickly copy the test case from here. Now, if I run this, let me run again. Yeah, so it gives me the correct indexes of the segments wherein I will be buying and selling my stock, right? 0, 3 and 4, 6, as we had seen like while we were explaining the problem, right? So this is the result entirely. And talking about the space complexity, since we did not use any extra space over here, it is going to be order of 1. It will be constant space. And talking about the time complexity, we are just iterating over the entire array once, and we are not doing anything else. So it will be order of n. It will be linear time. So the time complexity will be order of n, and the space complexity will be order of 1, right? So this is the solution entirely, and I will see you in the next video. Thank you.